All right, so for this next question, we see what happens when we start to mix and match information between angles and sides. If we have all sides, then we can use Pythagorean theorem to find missing information. If we have all angles, then we remember that triangles add up to 180 degrees. But when we have a little bit of both, we do have to dip into what might potentially be new math for you. All right, so to find an x component of a velocity vector. So you know the magnitude, which means in our purposes, you know the hypotenuse already. You know the angle over in the corner. What we don't know is what is this particular piece. Because we don't know what the vector is, we could say that it's v for velocity, or you could think v for vector. But in our textbook and our other references, typically it was just the first vector, it's vector a. And so if I'm looking for specifically the x component of vector a, then we call that ax. So hopefully that should be relatively straightforward. You can check your formula sheet and find the formula for this. So to find an x component to vector A, we take the original magnitude, which is the number part here of A, and we multiply by a special function called cosine of theta. So theta, the Greeks came up with this a long time ago, so they got to pick the letters. Theta is kind of like letter T. Think of it as just a variable. Specifically, it means a variable that has something to do with the angle. All right. The good news is that you have a calculator that can figure this out for you. The slightly bad news, it's not too bad, is that depending on your calculator, you may have to type this in a different way. So occasionally you can type everything straight on in, hit enter, and it's fine. Sometimes you have to change your mode because your calculator can switch between different formats for angles, or some calculators make you just kind of type everything in reverse order. This is something that you should hopefully figure out soon. You want to make sure you use the same calculator for the whole semester. That way you're not switching back and forth between input methods. All right, but here we don't know the x component. We do know that the original was 13.99 meters per second. Cosine is just part of the definition and how we draw these out. It helps if I spell it correctly though. And then the angle this time, theta, remember, is to do with the angle, is the 29.43 degrees. 43 degrees. There we go. What you may need to do if you're not fully comfortable with your calculator is to try to do the trigonometry part first. So if you take cosine of 29.43, you get 0.870956, and probably goes on forever. Um, if you're going to do that separately, make sure you write down at least 4 decimal places that aren't zeros, so hopefully everything rounds back to the same answer. Then take that and multiply, or if you get lucky, your calculator lets you type it straight in. Either way around, hopefully your final answer is 12.18. Now, depending on your calculator and where you rounded, sometimes you'll have an answer that's a tiny bit off from this. But think about money. You don't want to be off by more than about 2 cents. So 12.17, 12.20, those would be close enough. But anything further off from that means you probably made a mistake, or need to switch your calculator mode.